Welcome back again to Index Zero. In our last video, we learned how to use an infrared sensor diode and remote to control a light. Today, we'll be working with another display component, the 8-segment LED, and we'll make it respond to an IR mode. As always, I'm joined by Lance and Nancy to guide us through the project. Let's get started.
An 8-segment LED display consists of 7 LED bars arranged in the shape of an 8 plus a small decimal point. Each bar is called a segment and is labeled from A to G with a dot labeled DP. By lighting different combination of these segments, we can display the digits 0 to 9 and some letter. There are two types of display: common cathode, where all the cathodes are tied to G and D, and common anode, where all the anodes are tied to plus 5 voltage. The one we're using today is common anode, so the middle pins are both connected to 5 voltage and Arduino turns on each segment by driving its pin low. This makes it easy to show numbers or symbol while using only one display component.
So the materials we needed for this activity are Arduino Uno, prototype shield, breadboard, 8-segment LED display, common anode, IR sensor diode, receiver module, IR remote control, 220 resistors, one for each segment, and jumper cables. So to assembly, place the 8-segment LED display into the breadboard according to the diagram on screen. Connect both middle pins, common anode, to the Arduino's 5V pin. Each of the segment pins, A, B, C, D, E, F, G, and DP, should be connected to separate Arduino digital pins through 220 resistors. This ensures that current is limited for each LED segment because its common anode. A segment lights up when its Arduino pin is driven low. Next, set up the IR sensor diode. Connect the out pin to Arduino digital pin 11, the VCC pin to 5 volts, and the GND pin to ground. With this assembly, Arduino receives signal from the remote and displays the corresponding digit by lighting up the correct segments.
On the screen is the code for AP15. Let's break it down. First is in library inclusion. We include the IR remote.h library, which allows the Arduino to receive and decode signals from an infrared remote. Then the setup. We declared two variables. Receive pin equals 11, which tells the Arduino that the IR receiver is connected to digital pin 11. Then int current number, which keeps track of the current number displayed on screen or on the segment LED. Then the long code array houses the remote control codes or the hexadecimal codes on each button of the remote. And next, second array is a number segment patterns array, which represents the digits 0 to 9 on each row. Then next is a function to show the number, void number show, which takes an int I, then loops through pins 2 to 9, then writes whether high or low based on the number on the current iteration, then displays it on the digital segment. The setup: we start serial communication at 9600 frequency or about. We enable IR reception using the IR receive that enable IR in function. Then we configure pins 2 to 9 as outputs for the display and initially sets them as high, which turns off the segments depending on wiring. For the main loop, the if statement IR receive that decode the reference results, checks if an IR signal was received. If yes, decode into results value, then loops through all known codes. If a direct number is pressed or it matches a code, then it shows that number. If an advanced button is pressed, then it will go to the next higher number. Then move If a move back button is pressed, then it reverts back or decrements to the last number. Then the serial print resolves that value, prints the received code for debugging. IR CV.resume prepares the I receiver to accept the next signal. And that's the whole code. Let's see that in action.